You ever wonder what's really going on behind the screen of your favorite app? You know, there's this hidden structure, this digital blueprint that turns an idea into something you can actually use. Well, it's called the software development lifecycle, and today we're going to break that blueprint down piece by piece.
I mean, it's a fair question, right? From the outside, it can look like magic, or maybe a little more realistically, just a blur of frantic typing and energy drinks. But is that really how complex, reliable software gets made? Is it just pure chaos?
Well, it turns out the experts agree. Without a solid plan, building software absolutely can become a chaotic activity. And that chaos, it leads to bugs, missed deadlines, and projects that just completely fail. So how do the pros bring order to all that chaos?
They use the Software Development Lifecycle, or SDLC for short. Just think of it like a roadmap. It's this structured process that takes a team from a raw idea all the way to a finished working product. It's all about ensuring quality and control every single step of the way.
So, here's our game plan for today. First, we'll talk about why you need a plan to avoid that digital chaos. Then we'll see how the blueprints get drawn, followed by the actual construction and inspection. After that, we'll cover the big launch and how to keep things running. And finally, we'll look at two very different building styles you've got to know about.
Okay, so first things first. The most important idea here is that you can't just jump in and start writing code. I mean, that's like a construction crew showing up to an empty lot and just starting to pour concrete without any plans. You'd never do that, right? You need a strategy first.
And that strategy starts right here, in the planning stage. This is all about turning a kind of vague idea into a super detailed architectural plan. It involves two key phases that happen long before a single line of code ever gets written.
Okay, so it all starts with communication. And really, this is pure investigation. It's about asking questions, and maybe even more importantly, listening. What problem are we actually solving here? Who are we solving it for? Because if you get this part wrong, you risk building a perfect piece of software that absolutely no one wants or needs.
Let's make this real for a second. Imagine you're building a banking app. The requirements aren't just, let people see their money. No way. They're incredibly specific. You need secure fund transfers, you need high-level encryption, and you absolutely must comply with all these complex financial laws. Defining these things right up front, it's completely non-negotiable.
So, once you know what you're supposed to build, you move on to modeling, or what we usually call design. This is the part where you figure out how you're going to build it. You're creating the technical blueprints, the system architecture, how all the data is going to be organized, and what the user interface will actually look and feel like. And this quote right here, it really drives home our central analogy. Just as a builder needs architectural blueprints, a software engineer creates models to understand the big picture. It's perfect, right? It's what lets the team see the entire project from a high level and spot potential problems before they become these incredibly expensive mistakes to fix later on. So for an e-commerce site, that blueprint would detail everything. I'm talking, how are the products and user accounts stored in the database? What does the checkout process actually look and feel like for a customer? And a big one, how is the system going to handle a massive surge of shoppers on Black Friday? Answering these questions in the design phase is what separates a successful online store from a broken one that crashes.
All right, so our blueprints are approved, and it is time to break ground. This next major activity is construction. And just like in the real world, it's not just about building, it's also about inspecting the work as you go. So the first part is coding. This is the phase that most people picture when they think of software development, right? It's the skilled craft of taking all those design documents, all those blueprints, and translating them into a programming language that a computer can actually understand. So for a fitness app, this is where a developer literally writes the code to connect to the phone's GPS and start tracking a run. But, and this is important, happening right alongside the coding is testing. And look, this isn't just some final check at the end. It's a constant process of quality inspection. The goal is simple, but it is absolutely critical. Find the bugs before your customers do. And this inspection, it happens at a few different levels. First up, you've got unit testing. That's where you check the smallest individual pieces, like making sure a single interest calculation is correct. Then you zoom out to integration testing. This is where you see if those pieces work together. For our banking app, does deducting money from one account actually add it correctly to another? And finally, you have validation testing, which asks the biggest question of all. Did we actually build what the customer asked for in the first place?
So, the software is built, it's been thoroughly inspected, now what?
Well, now it's time for the customer to move in. This whole section is about the launch and really the ongoing life of the product.
The next official phase is called deployment. This is the go-live moment. For our e-commerce site, this means uploading all the code to the live servers, pointing the domain name to it, and flipping the switch so real customers can start shopping. It's officially move-in day.
But here's the thing. Unlike a house, software doesn't just sit there once it's built. It needs constant maintenance. Now, software doesn't wear out like a physical thing, but it does deteriorate if it isn't updated. Think about it. It has to adapt to new operating systems, new security threats, and new things that users want.
And get this, here's a staggering fact for you. For many large projects, maintenance can eat up more than half of the total cost over the software's entire life. Just let that sink in for a second. For a lot of teams, the real work has only just begun on launch day. Okay, so now that we understand all the phases, the what, let's spend a minute on the how. It turns out there are different process models, or building styles, if you will, for actually getting all this done.
The two most famous styles are waterfall and agile. Now, waterfall is very linear. You finish one phase completely before you even think about starting the next. It's like building a house, floor by floor, from a fixed, unchangeable blueprint. It's perfect if you know exactly what you need from day one. Agile, on the other hand, works in these small, rapid cycles. It's more like building and perfecting one room at a time, and you're constantly adapting the plan based on feedback. This flexibility is exactly why it's so popular today for things like web applications where stuff changes all the time. So, what's the big takeaway here? What's the digital blueprint? First, the SDLC brings order to what could be digital chaos. Second, it's a whole journey, from a simple idea all the way to a launched product. Third, and this might be the most important part, plan your blueprint before you start building. And finally, remember that software isn't static. It's a living thing that needs constant care to thrive.
So I'll leave you with this final thought. The next time you open an app on your phone, just take a second. Look past the buttons. Look past the graphics. Can you see the structure? Can you maybe even see the blueprint hiding just behind the screen?